So basically for today, we're going to finish chapter 2. I don't think it makes a lot of sense to start chapter 3, but we'll see how it goes when we spend a little bit more time on equalities. So, equality is the relationship, thank you, relationship between two units, okay? Okay, so let's get back to this. Equality, right? Relationship between two units. This is one of the examples. 1 meter equals 100 centimeters. Or 1 centimeter equals 10 millimeters. Okay? Those are just examples of inequalities. You can say that 1 kilogram equals 1,000 grams. Okay, makes sense? So these are equalities within the length. Let's write some down, shall we? So 1 kilometer equals what? 1,000 meters. 1 meter equals how many decimeters? Deci is 1/10. So it should be 10. Or 1 meter equals how many centimeters? Centi is 1/100th, so 100. Or 1 meter equals how many millimeters? Milli is 1,000th, so 1,000. My bad, extra zero. Okay, makes sense? Now, tell me please, considering what we just wrote, 1 decimeter equals how many centimeters? How many millimeters? 100. And 1 centimeter equals how many millimeters? 10. Sounds good? See how convenient metric system is. The volume, you can't do that. Remember that conversation that we had before? Okay, so for instance, when we measure volume, okay, this is 1 cubic centimeter. Okay, and here's something, so it can be written like this. 1 cubic centimeter can be written as centimeter cubed or cc or 1 ml. Let's go back to this, folks. I'm going to ask you a series of questions that are based on what we've already learned. So 1 decimeter equals how many centimeters? 10. You follow me? 1 liter, as you may remember, is equivalent to 1 decimeter cubed. This is the definition of a liter. Okay, good? So it means that 1 liter equals 1 decimeter multiplied by 1 decimeter multiplied by 1 decimeter, or 10 centimeter multiplied by 10 centimeter multiplied by 10 centimeter. 10 multiplied by 10 multiplied by 10 will give you 1,000 cubic centimeters. And if 1 liter contains 1,000 cubic centimeters, then 1 cubic centimeter is 1. So we can say that 1 centimeter cubed is 1,000th part of a liter. Would you agree with me? Yes? Yes? What do we call 1,000th milli? I'm going to stop. I'm going to ask. Did you follow or you got lost? Not a single person in particular. I'm just asking all of you. Okay? Thank you for saying this. We're going to do sort of a check mark here. The statement that 1 decimeter equals 10 centimeters. Do you agree with that? The statement that 1 liter equals 1 cubic decimeter. You can say no. It's totally appropriate. No? Okay. The definition of a liter, I probably shouldn't have skipped that. I'm going to put it on top here. I'm going to do it graphically, not by words. Liter is the volume of a cube with a side of 1 decimeter or 10 centimeters. Make sense? So, how do we calculate the volume? So, length, height, and width here is 10 centimeters. Good? So, length, height, width. Good? 1,000 cubic centimeters. Now, from this equality, we can say that 1 cubic centimeter represents 1,000th part of a liter. And if you go back to that table with the prefixes, 1,000th is a milli. Better? Fantastic. So basically the point that I want to make is that don't do the common mistake if I ask, how many cubic centimeters in a cubic decimeter? So, well, this is 1/10, sun is 100, it's got to be 10. No, it's not, because it's a volume now. It's going to be 1,000. Right? Okay. Yeah, syringe. Mass. Pretty straightforward. I'm actually not going to write anything myself, because those are the equalities that chemists use, and that's about it. I never used centigrams in my life, ever. It's kilo, regular grams, milligrams, micrograms. Okay? So, units, larger unit in each of the following. Here, millimeter or centimeter? Centimeter. Kilogram or centigram? Deciliter or microliter? Microgram or milligram? There you go. And 1,000 meters? support me. 0.01 meter. Which unit matches it? So this is 0.01 meter. Which one? Huh? Centimeter, yeah. 0.01 is 1/100th, right? Does that make sense? Awesome. 1 kilogram. How many grams? Kilo is 1,000. This is one of my favorite examples. Is there a correct answer? Okay. Huh? Look at this. So centi is 10 in the negative second, right? So we have 0.01, 10 multiplied by 10 in the negative second liter. There is no right answer. Okay, let me do it again. We're gonna go between the exponential notation and this notation. So, would you agree that this is the same as this? Perfect. Perfect. Now remember that the small letter C means centi, right? 1/100th. So would you agree with that statement? Okay, good. If you want, I can scroll up to the table, but it will show you exactly the same. Good? So what we can do, we can say now that it's 10 to the negative 2, 10 to the negative 2, 10 to the negative 2 multiplied by 10 to the negative 2 gives you what? 10 to the negative 4 liters, or this, but there's no such answer. One more time, we're moving on. Go on. I convert centi into its mathematical meaning. So I can say that 1 centiliter is, okay, not I'm going to say. I'm going to make some statements. I'm going to ask you if you agree, okay? So 1 centiliter is 1/100th over liter. Do you agree with me? Good. Can I replace it with this? Yeah, that's it. Basically, it's a multiplier. Centi is a multiplier. So these are some equalities between metric and imperial systems, okay? To be fair, like when you start thinking in the framework of all those factors of 10 and 1,000 that we use in the metric system, you don't need these equalities. You just, think, okay, I multiply by 10 and divide by 10. But for metric versus imperial, you have to. And I want you to just compare the metric column and the US column. Okay? I mean, just watch Nate Bargatze. Seriously, just watch this little bit. It's like 3 minutes. It's glorious. It explains everything. So all I want to highlight is that if you look at the metric system, it's very logical, right? It's all about tens, hundreds, and thousands. We have 12 inches in a foot and then 3 feet in the yard. That's weird. Yes. And then we have, okay, I'm gonna shut up about miles. Just watch that bit. Okay, so it makes sort of sense when we talk about like applying it to measurements in the kitchen, a cup, sure. But then a gallon, a quart, like no, that makes very little sense. Okay? Again, you don't have to memorize those conversion factors, those equalities. They all will be on the handout. Okay? So if I ask you to convert 75 kilograms into pounds, you will know that 1 kilogram is 2.2 pounds. You just got to do math, right? And this brings us to the conversion factors, which we're going to use a lot in the course. So when you take an equality like this, okay, you can write it as there's 100 centimeters in 1 meter, or 1 meter contains 100 centimeters. Okay. So it can be written for anything. Like we do some fancy boring stuff. Do you remember what was the price of a gallon when you were fueling your car recently? Say again? Perfect. So what does that mean? It means that 1 gallon, price-wise, is this, right? You can write conversion factors. You can say that $3.27 will buy you 1 gallon of fuel. Or you can say that 1 gallon of fuel will cost you $3.27. You will see the reason why I use this. So imagine you need 5 gallons. Okay? So how much money you'll have to pay. This is the rule that is I think it's very easy to remember. Two at the top, from on the bottom. So in this case, you need to buy 5 gallons. You need to convert it into money. I know, it sounds stupid. You can do it in your head. I'm just illustrating that you're using conversion factors in life all the time. So, we have 5 gallons. You have to go from gallons to dollars, right? What goes on the bottom? From 1 gallon. What goes on the top? $2. How much 1 gallon costs? $3.27. Right? Gallons cancel each other out, and I don't care about the results really. Here's another thing. You have $20 in your pocket. How much fuel you can buy? So, you have $20. You have to go from dollars to gallons, right? Am I making sense? So from on the bottom, 2 at the top, whatever. I never finish these calculations because I find it like, I know that you can press the keys on the calculator, so it's fine. Make sense? This is the example of conversion factors. Okay? We're just going to be using these conversion factors for different units. So if we talk about liters and milliliters, what is the equality between them? 1 liter equals 1,000 ml. Give me one conversion factor. One liter contains 1,000 ml, right? Or you can flip it depending on what you need. Okay? Inches and meters. Well, I'm going to tell you. 1 meter is 39.4 inches. So a conversion factor that you can write is 39.4 inches comprise 1 meter. Sounds good? C is trickier. A little, not by much. So, milligrams, micrograms. Yes. Can you explain it? Can you explain why? So, you're absolutely correct. So, 10 to the negative 3 is milli. 10 to the negative 6 is micro. The difference between them is 1,000 times. Does everybody follow? And you can write the conversion factor something like 1,000 micrograms comprise 1 milligram. Cool? Again, meters and decimeters. Hmm? 10. That's B is nice. What is percent? Huh? Yes. So that's a conversion factor. Percent. Okay? And we already did gallons, so I'm not gonna waste our time on the price that is not coming back anytime soon. That's perfect. So let's solve this problem. A person weighs 178 pounds. So this is the unit that you have to go from, right? And which unit you have to go to? Kilograms, yes. Yes, but what goes on the bottom? What goes on the top? Kigs. And now we can put numbers in. We can say that 1 kilogram is equivalent to 2.2 pounds. Do the math, I don't care. Oh, equality. Just, okay, fair comment. 1 kilogram is equivalent to 2.2 pounds. Does that make sense? Okay. How about we're gonna make it slightly, like, okay, we can do centimeters and let's do inches as well. Okay? So if rattlesnake is 2.4 244 meters long, you have to go into from meters to centimeters, right? Everybody agrees? Where should meters go? Centimeters? What number should I put on top? Go on, say it out loud. 100. Don't be afraid. Like, I'm not gonna make fun. Okay, you said something. This is not the answer. Go on. Whatever you want. Absolutely. Absolutely. Perfect. Yes, 10 to the second. It's fine. Yeah. And 244 centimeters. Okay. If you would want to do meters, instead of meters, inches, what would you do? So again? We have a conversion factor. I'm curious, where would you put each individual units, huh? That's it. Okay? That makes sense. Good. Now, what if you have to use multiple conversion factors? Because sometimes, let's say you want to go from milligrams to pounds. You will have to make several steps, right? Grams and then pounds. So you may use more than one conversion factor. You just line them up, you multiply them. So here, you have, what is the starting unit? Let me ask you, what is the starting unit in this problem? Milligrams. What is the final unit? Tablets. Okay. So you start with milligrams and you end with tablets. Okay? Good? So in order to get to the tablets, you know that one tablet, so let's write some equalities, okay? You have this microgram unit here, correct? So we need to write, first of all, the equality between milligrams and micrograms. You already told me this. What's the equality? One milligram is equivalent to 1,000 micrograms. And then we have to write an equality about the tablets.
What is that little dash in front of microgram?
I think it's a typo. I think it's a typo because they wanted, or maybe intentional sort of typo, because they wanted to highlight that this number 50 contains two significant figures. That 0 is not just a placeholder, it's actually like decimal point. So one tablet contains how many micrograms? Okay. So we will need to use two conversion factors. Which conversion factor would you use first? What goes on the bottom? What is the number at the bottom? Top. What is the next conversion factor? Micrograms on the bottom. Tablets on top. What numbers? Say again? Yes, but where and where?
One tab for 50 micrograms.
This is why I left chemistry. My master's is in chemistry. They too pedantic. Just rubs me the wrong way. How you check that you are doing everything right? You cancel units. MIGs cancel each other out. Micrograms cancel each other out. You've got tablets. 3. Yeah. Okay? Does that make sense? Minutes in days. Again, what is your starting unit? Start. Right? The starting unit is the unit you know the amount of, the quantity of. That's your finish. Good? Clear? Okay. Now, this is kind of practical. Do you know how many minutes are in one day? I do, but it's beyond the point. So, do you know how many hours? 24. So what goes on the bottom? Top. Do you know how many minutes are in 1 hour? What goes on the bottom? Top. And then whatever. Okay. Good? The whole concept. And again, I very much recommend checking by crossing this stuff out. And that's another one here. So 65 meters per minute. What is the starting point? You have two actually. What is the starting unit? That's the conversion factor. You see what I'm saying? Your pace equals 65 meters per 1 minute. You see, this is the conversion factor. What is the starting unit? So you have 7.5 kilometers. Okay? That makes sense? But your conversion factor that we have here is in meters, so you have to go from kilometers to meters. How? It goes on the bottom. Top. Okay. Now, you need to write this conversion factor in the proper shape and form. What goes at the bottom? Not all together. Meters on the bottom and minutes on the top. 65 meters, 1 minute. Okay? Cancel out meters and you get the answer in minutes, which, again, you can press the buttons. Does that make sense? You will absolutely get questions that will ask you to convert things. Did I mention the note card? 2 sides, 1 standard note card. If you want, you can bring scratch paper. I want to see that it's like just plain scratch paper. That's it. Please, I know the calculations are more convenient to do on the side. Yeah, that's fine with me. Okay? We already discussed what density is. So, mass over volume. Units what would be the unit of density in international system? What is the unit of mass in international system? And the volume? That's centimeter. Meter cubed. Okay, so this is, I'm going to give you some convenient cheats. So this is the unit in international system. Okay, this or this are the units that chemists usually use. Okay, am I making sense? Good. So I can tell you that the quantity, the number for the same material will be the same with both units. So for instance, mercury, if my memory serves me well, is 13.6. No, not cubic meters. Yeah, ignore, it's a liter. But yeah, those are units that are used in metric system and the international system. Higher density means that the substance will sink, right? Overall, think of it this way in terms of floating. If the density of a substance is less than the density of the liquid, it's going to float. If it's higher, it's going to sink. Make sense? If it's the same, it's going to kind of hover somewhere in the middle. So let me ask you this. If you will take an axe, okay, and throw it in the water, will it sink? I'm talking about like the metal part of it. If you will take that same metal part and throw it in a little can with mercury, will it sink? It will not, because the density of iron, again, ballpark, 7.6 grams per centimeter cubed. That's iron. Density of mercury is, I think, 13.6 or 13.8. So you see, the density of liquid mercury is greater than the density of iron, so it's not gonna sink. Okay, make sense to you? So metric system, the one that we're going to be using for the most part, already mentioned, gram per cubic centimeters or grams per milliliter. Grams per cubic centimeter, that's for solids. Gram per mil is for liquids. For gases, since they are so not dense, gram per liter. Okay, so I want you to take a look at this table and answer some of my questions. So let's talk about humans. Will you sink in water? Let's say it's not 4 degrees, let's say it's a little warmer, but still warm, okay? Will you sink in water? Okay. Will you sink in ocean water? Like, why? What does it make ocean water? What parameter of ocean water does salt make greater? The answer is literally on the slide. Density, yes. Remember you were measuring density of deionized water versus sodium chloride? Sodium chloride was slightly up. Who will sink faster, an average person or a bodybuilder? A bodybuilder, they have more muscle. Okay? Will you sink in blood? No. Look at this. The density of the blood is 1.06. In your body, the density of the muscle is 1.06, but the density of fat is lower. So you will actually float in blood. Okay? Few more. Will lead float in mercury? Yes. Will gold float in mercury? No. What's going to happen? I'm utterly enjoying this. What's going to happen if you mix mercury and water? Huh? What's going to happen to mercury in water? Dude. Mercury. Look, density of mercury is 13.6. Density of water is 1. Mercury will sink. This is how mercury is stored in chemical labs. Because the vapors are dangerous, so the mercury is literally covered with deionized water. It's extremely inert, so there are no reactions. Osteoporosis, you lose calcium, so you lose bone density. Yeah, thank you for the example. Okay. Yeah, it's not great. If you don't eat enough calcium, you're going to develop osteomalacia, which is similar to osteoporosis, but osteoporosis is age-related. Loss of bone tissue. If you want to prevent it, exercise, please. Okay. So, remember, density is a conversion factor. You can write this conversion factor down like this. 132 grams of that liquid can be found in 1 milliliter of this liquid, or 1 milliliter of this liquid contains 1.32 grams. Does that make sense? Okay. Now, what is the starting unit that we're working with? No. Remember, 1.32 is a conversion factor. We need one single unit, and we have it here. That's grams. Right? That's the start. That's the finish. Okay? So our start is 14.7 gram. In the conversion factor, what should go on the bottom? Whatever. I really don't care about the numbers in this case. Does that make sense to you all? So, I'm going to elevate it a little bit. I want you to identify the starting units, the final units, and 2 conversion factors present in this problem before we start solving it. What are the starting units? What are the final units? What are the conversion factors? Grams per mil. Exactly. And 5 ml per teaspoon. Okay? So we start with 2 teaspoons. Okay? Sounds good? Which conversion factor should I use first, left or right? The right? Well, should I ask you what goes on the bottom? Now, in which form should I use the second conversion factor? Say again? Yep. Yeah, whatever. Again, you can calculate it. Yeah, we're gonna finish specific gravity. I'm gonna say something nice to you, and then I'm gonna kick you out. We assume that the density of the water is 1 gram per mil. Strictly speaking, it's 1 at 4 degrees, and it becomes less than that whether you go below or above. Okay? But basically, specific gravity, density of the sample versus density of the water. Okay? So remember, you were measuring the density of 5% sodium chloride on Monday, right? You got some number. You take this number, you divide it by 1, you get specific gravity. Okay? Does specific gravity have units? That's a tricky question. Does specific gravity have units? You know, like milliliters or whatever, grams. No, because it's a ratio. Okay? It's sort of, it's 1 point, I don't know, 1.03 greater than the density of water. Okay? And yeah, specific gravity is the parameter that is measured for urine. Diabetes decreases specific gravity because people fail to excrete enough solutes, yes. But so specific gravity is usually determined by this truth. So actually, we're going to do it at some point in the course. We're going to have a lab. We're not going to work with actual urine unless you really want. Sure. But by the way, do you know how diabetes was diagnosed before all the fancy analysis? Yes, that's one way to do it. It's sweet. Glucose. Well, it's when it comes out, especially if it's midstream, it's sterile. It's just a water with a bunch of salt and other substances. There was another way to do it. It took a little longer and worked only in the summer. There was another way to do it. It took a little longer and worked only in the summer. Mhm. Flies. They put it on the windowsill, and if it attracts a lot of flies, there you have it. Because it's sweet, because there's glucose. Okay?